evening. We are still on matrices and determinants. Today we are going to use the determinant methods to solve our x, y, z in this simultaneous equation. And this determinant method is also called Cramer's rules. You may see it in the equation, say use Cramer's rules to solve this equation, or you say use determinant method. And we have to write this one in the matrices form. Use write out in matrices form. How can you write this in matrices form? This is 2. We are taking the coefficient 2. This is minus 1. This is 1. This is 1. This is 1. This is 3 rather. 3. This is 2. And this is 3. This is minus 1. And this is 1. We're taking the coefficient. And what are we looking for? We're looking for x, y, and z. X, y, and z. Then the answer now 0, 16, and 3. This is how to write this in matrices form. Now, the first thing I will do, it has 4 steps. I want to find the determinant for all, delta s, delta y, and delta z. Now, how can I find delta for all? I'll pick this one out. We have 2. We have minus 1, 1, 3, 2, and 3, minus 1, and 1. This is what I have. And remember, if I want to find determinant from my previous video, we add plus here, plus, minus, and plus. This is how to find delta odd. I will say delta naught. Delta naught is equal to, the coefficient here is 2, then square bracket, that's with the columns and rows. We have 3, 2, minus 1, 1. Then this minus times minus is now plus 1. Then cancel the columns and rows. We have 1, 2, 3, 1. So now here is now plus 1, square bracket, cancel the columns and rows. We have 1, 3 minus 1. So now we have delta naught is equal to 2, open bracket, 1 times 3 is 3, minus 1 times 2 is now minus 3, change to plus 2, plus 1, open bracket, 1 times 1 is 1, minus 3 times 2 is 6, plus 1, open bracket, minus 1 times 1 is minus 1, minus 3 times 3 is now 9. So we have delta naught is equal to 2, open bracket, 3 plus 2 we have 5, plus 1 minus 6 we have minus 5, plus 1, minus 1 minus 9 is minus 10. So we now have delta naught is equal to 2 times 5 is now 10, plus times minus we have minus 5, plus times minus we have minus 10. We have delta naught is equal to 10 minus 5 is 5 minus 10, which is equal to minus 5, which means delta naught is now minus 5. I have to find delta x, delta y, and delta z. How can I find delta x? This is the column for x, this is the column for y, this is the column for z. So for column x, if I want to find delta x, I will replace this column with the answer here, which is the first thing I will write here is now 0, 16, and 3. All the remaining one is now constant, which is minus 1. 3, minus 1, 1, 2, and 1. So this one is, I'll use this one to find delta x. As you can see now from the previous answer, this one has changed. I'll replace this one with not the answer. So I want to say plus, minus, plus. We now have delta s. Delta s is equal to, using the same method. Here is plus 0, that is 0. Then I'll pass on the columns and the row. We have 3, 2, minus 1, 1. 3, 2, minus 1, 1. Then we have minus times minus is now plus 1. Then cancel the columns and row. We have 16, 2. 16, 2. 16, 2. We have 3 and 1. 3, 1. Then plus 1. Then we have cancel the rows and we have 16, 3. 16, 3. 3 minus 1. So this is what I have. I have delta s is equal to 0 multiplied by everything is have 0, plus 1, 16 times 1 is 16, minus 3 times 2 is 6, plus 1, minus 1 times 16 is minus 16, minus 3 times 3 is now 9. We have the delta s is equal to 1 times 10 is 10, plus times minus is minus 25. We have delta s is equal to minus 15. So we have to find delta y. How can you find delta y? This one because first and from the previous the first instance, this one is 2. We have to leave it where it is 2, 1, 3. Is this one the volume of y we're going to change to answer, which is 0, 16, and 3. Then we leave this one constant 1, 2, 1. Using the same method, we have plus, minus, plus. Here we have delta y is equal to here is 2. Cancel the columns and rows. We have 16, 2, and 3, and 1. Here is minus 0. Cancel the rows and columns. We have 1, 2, 3, 1. So then plus 1. Cancel the rows and columns. We have 1, 16, 3, 3. Cancel the rows and columns. 1, 16, 3, 3. We have delta y is equal to 2 open bracket 16 times 1 16 minus 3 times 2 6 minus everything here is now 0 plus 1 3 times 1 3 minus 3 times 16 48. We have delta y is equal to 2 open bracket 10. This one is 0 plus 1 open bracket 3 minus we have minus 45. We have 2 times 10 we have 20 minus 45, which means we have this 20 minus 45 we have minus 25. That is for delta y. Remain delta z. How can I find delta z? I'll claim my question. Delta z, I'll use this one to replace it. That means this one will be constant, y will be constant, y will be constant, which is 2, 1, and 3, minus 1, 3, minus 1. Then they will replace this z column by what the answer 0, 16, and 3. This is what I have, then plus, minus, plus. So I'll claim the remaining one. So with this, I can now find my delta z. Delta z is equal to 2. Cancel the rows and columns. We have 3, 16, minus 1, 3. Then minus times minus is plus 1. Cancel the column and row. We have 1, 16, 3, 3. Then plus 0. Cancel the rows and columns. We have 1, 3, 3, minus 1. So we have delta z is equal to 2 open bracket 3 times 3 is 9. Minus 1 times is minus 16 is plus 16 plus 1 3 times 1 is 3 minus 3 times 16 is 48. All this one is now 0. Anything multiplied by 0 is 0. So we have delta z is equal to 2. 9 plus 16 is now 25 plus 1. 3 minus we have minus 45 plus 0. Delta z is equal to 2 times 25 is 50. Plus times minus is minus 45. Is equal to 50 minus 45 is now 5. So now, how can I get x, y, and z? From here, I cannot say my x is equal to delta x all over delta naught. Then my y is equal to delta y all over delta naught. Then my z is equal to delta z all over delta naught. This is how I'll get everything. What is my delta s? Delta s is minus 15. Delta naught is minus 5. Then delta y is minus 25. And delta naught is minus 5. And delta z is 5 all over minus 5. Here, if I do the minus cancel minus, we have 3. Minus cancel minus, we have 5. We have minus 5, the other we have 1. Which therefore x is equal to 3, y is equal to 5, and z is equal to minus 1 respectively. Please do